Hey guys, welcome back to my YouTube channel. Today we're gonna be discussing on DDR3 memory interface with our SoC. But before discussion, I wanna apologize for delay in making videos because I really didn't get time to do that. So today we're gonna be doing DDR3 memory interfacing with our SoC. But before moving over to that, let me point out some of the necessary signals that are needed to be considered while interfacing our DDR3 memory chips with SoC. Okay, so let me open up my Microsoft Word, which is down here. Okay, Okay, here I have listed out some of the necessary signals that are needed to be considered while interfacing DDR3 memory chips, which are SoC. Okay, on the left side, we've got this bunch of address command and control signals. Okay, this is a 16-bit address lines which are used for carrying address information. And then we have three bank selection address lines, which are for selecting, the carrying bank selection address bits. And then we have here two command signals, RAS and CAS. These two are active loss signals and they are for selecting rows and columns of our DDR3 memory chips. Okay. Now what are DDR3? What are rows and columns? Each memory SDRAM is organized as a matrix with rows and columns. Okay. So for selecting those rows and columns, we got these two command signal labeled as RAS-N and CAS-N. Okay. And then down here I have ODT stands for on-die terminations. This is for enabling the termination register in order to prevent the reflections. Okay, which is pretty important in terms of signal integrity. Okay. And then I have here is clock enable signals. Okay. Okay, for enabling the clock signals. And then we have here is CS, that is chip selections, which determines which particular chip is being used. Okay, and then we have here is differential clock signals, and then this on the other side we have 16 bits bidirectional data lines, and in order to indicate the data bits on the data lines are valid, we use this 3 bits. Okay, this is sorry, this should be one only. 2 bits data mark signals for each byte length for lower and upper. And then we have two pairs of data stop signals. Okay. Now they are labeled as DQ as positive and DQ as negative. Now let me describe what is data stop signal. A data stop signal is used to capture the data on both ends of the stop signal for higher data rate. Okay, and it has to be remembered that these signals work together to facilitate efficient communications between memory controller and the DDR3 memory module. Okay, so these are the necessary signals needed to consider while interfacing DDR3 memories. So now let us move over to our actual interfacing of DDR3 chips with our SoC, which I have already done. Okay, so let me open up my Ultimate Designer here. Okay, so here it is. So on the left side, I've got SoC, and on the other side, I have here SDRAM. Okay, so here I've got this bunch of address signal on this memory chip, sorry, SoC. But as you notice here the address bits, the address lines, these address lines are not, interfaced with our SoC, sorry, SDRAM, address lines accordingly. Okay, they are interfaced randomly, so to speak. Why? Because I'm following design guide while interfacing these address lines with our SDRAM chips. Otherwise, this SS7 should be SS0. Okay, as you can see here, the net labels are not pressed accordingly. Okay, you may be wondering it is for swapping the address bits. No, it is not for that. The address bits cannot be swapped. But I'm following design guide only while interfacing. Okay, I'm repeating this once again. Okay, as you can see here on the SA0, I'm putting this label SA7, SA11, SA1, so on and so forth. Even on the address bit of 3 on this SOC, I'm putting this row selection pin label. Okay, it means this SA3 is interfaced with uh, row selection pins of our signal pins of our SDRAM. All right, let me zoom out. And their interface according to the design guideline. Okay. However, in case of data byte lines, each one of those signal lines are labeled accordingly. Like on these pins, I'm putting this label SD, SD0, SD1, SD2, SD3. In case of DDR3 memory interface, we can swap the bits and even bytes. Okay. There is no restriction in that. However, in case of DDR4 interface, we can even swap the data bytes and as well as data bits. However, in the worst case, if we cannot, complete a layout, we can swap the bits in nibbles, which is exceptional. Okay, here, and this is for the calibration registers, which is 240 ohm. Pin is connected to this resistor. All right, and these are the filtering capacitor for this BCC DRAM. And let us look at the DDR3 memory. These net labels are being put accordingly on this memory chip. However, as you're noticing here, the data lines are not, labels accordingly. Like in place of, S data bit 2, sorry, data bit 3, label SDQL2, I'm putting this SDQ5. It means bit swapping. This is for the convenience of the layout. Okay, which I'm going to be showing you in the later videos. So stay tuned, hit the bell icon so that you won't miss the next upcoming videos. Okay, I have put here bit swapping. We can even swap the byte. Okay, but I'm not swapping the byte. I'm swapping only the bit. And it is recommended to put the least significant bits as it is. We cannot swap this. Yeah, we can swap, but it is highly recommended not to swap the least significant bit. As you can see here, SDQ0 is not swapped with anyone's. Okay, SDQ0 is being put on the same pin as it is, and in here also on the upper byte line SDQ8, which is the least significant bit for this byte line, for this particular byte line, it is being put on the same as it is. Okay, however, they're bytes, they're swapped, the rest are swapped. Okay, so these are the differential clock signals and then the data stop signals, and as you can see here, these are important data max signals. Okay, if I have to swap the byte, then this data max for lower bytes come down here, and upper byte for data max 1, that is for upper byte, would come up over here. On the lower data max, it would be like that. But I'm not swapping the bytes, so I'm not gonna swap this. It will remain as it is. Okay, so that is how we can swap the bytes and bits. All right, and this is on the terminations. Sort on the termination for selecting or enabling the termination resistor in order to prevent the reflection, and then for enabling the clock signals, we have here is clock enable signals, And then for selecting rows and column, we got these two command signals, these two signals, and this is for selecting this particular SIPs at the time while communicating with our uh, host controller during these operations, memory operations. And then we have here is write enabling. Okay, and then these three signals, which is the bank selection address, they are address signals, 16 bits. Okay, and these address command control signals are needed to be perfectly lang matched. Then differential clock signals have to be lang matched within plus minus 5 mils, which we'll discuss in the later videos. Okay, and these byte lengths have to be routed on the same layer and they have to be perfectly lang matched. Okay, but we can route the two different byte lengths on two different layers, and the length of the two bytes lengths need not to be matched. Okay, however, the each bit of a byte length needs to be perfectly length matched and routed on the same layer. All right, and this is for the reference voltage, and this voltage is created in the same voltage levels used for powering up both DDR3 memory chips as well as host DDR3 controllers section of the SoC, as you can see here. All right, and these are nothing but the filtering capacitor. Okay, each one of those can be shared with two chips pins. I mean, both memory as well as controller chips pins. If those pins are pretty close to each other. Okay, let me show you guys. Okay, one. Here you can see L9 and L10. These two are pretty close to each other, and if the space is pretty cramped, I mean, if we don't have enough room, then we can use one single capacitor for connecting these two. I mean, these two pins can use a single capacitor. Okay, and the old scenario, where the space is, I mean, the form factor, I mean, pretty small, than these three pins can share a single capacitor. Right. So this is it. And down here again we have this is DDR3 memory interface, and so same goes in here also, like address, data lines, clock. Okay, unlike in here, as you can see here, this bunch of resistors are connected in series with these address lines, and they're nothing but that ferrule termination resistors uh, in order to prevent the reflections, because these two memory chips are interfaced in 5 by topology, okay, for better signal integrity. Okay, and I'm designing these address lines, I mean single-ended, not only address line, any single-ended signal lines on this design is 50 ohm impedance. Okay, and I'm connecting 10% rather than the transmission lines impedance. Why? Because in order to prevent the undershoot. Okay. We still don't have the concept of the ferrule termination resistors. Okay, and why they have to be connected in high-speed transmission line. Please follow the YouTube channel, because there are many good YouTube channels out there on internet. So you please follow especially the YouTube videos of Philip Salma and Robert Perry. Okay, it's not like I'm advertising anyone. It's just for advising you to follow. If you still don't have the concept on termination resistors, when and how they have to be interfaced with high-speed transmission line. Okay, they are nothing but 10% larger than the transmission line impedance in order to prevent the undershoot. Okay, so this is it. And these are nothing but the decoupling capacitors. Yeah, because anything deviation that happens in these regions may lead to the failure of signal integrity. So I'm putting this on stop filtering capacity. Okay. So this is how the DDR3 memory chips are interfaced with a host controller in flyby topology. Okay. And if we have enough space and to interface multiple DDR3 RAM chips, it is recommended to interface those in flyby topology. However, if the space is cramped, I mean, if there are some exception, then we can interface to the three memory chips in branch topology. The host controller or the three memory chips allow point-to-point interface. So that's it for now, and hope you guys are following with me. And thank you guys for once again for sticking with me. Thank you.